So here's our lesson or our plan for today. And as we were talking yesterday, we did some discussion yesterday about vectors and scalars. And I saw some blank stares on your eyes for a little bit. Like, what the heck is he talking about? So what I want to do right now is I want to take a moment and see if you can do this for me. I think you guys yesterday, we wrote something down here, maybe a word or two, momentum, something I can't remember. But I'm hoping I left some space here. I'm going to ask you to create a diagram that shows how 3 plus 4 could be 5. Could be 5. So 3 plus 4 could be 5. See if you can remember how we did that yesterday, or at least how we used vectors as an arrow to represent a quantity that has a magnitude and a direction. Can you take and create a drawing in this space that shows how 3 plus 4 could be 5? 3 plus 4 could be 5. All right. Now, will you take a moment and share what your drawing looks like with your elbow partner, that person that you're sitting next to? So just, what did you draw? What did they draw? Let's see if you are in agreement. Okay. I don't know if you're listening to this at home, if you can hear all the murmur going on, but there's a lot of good discussion. I like it. Lily, can I pick on you for a second? You said you drew what? All right. So if you did not have a drawing that looked exactly like this is fine. Fix it. I'm going to show you sort of a summary of what we talked about yesterday. This could be a 3 meters. It could be something else that's 3, but it could be a 3 meter, in this case, sort of change in position that's sort of towards the right. Now, I could add to that, and this is similar to how I was walking yesterday, I could add to that a 4 meter kind of setup like that. And when I'm done, how I might show that it's actually the addition of 3 plus 4 is 5 is there'd be like, instead of an equal sign, I could have something that looks like this. Now, you didn't necessarily have this exactly the way that I drew that, but you could draw it like that. 3 plus 4 could be 5. I walk a distance of 7 meters, but I only end 5 meters from where I started. And the reason for that is that I had a change in direction. The hard part of a physics class is that we use a lot of vector mathematics. Almost everything, well, I can say not almost, everything in all of your other science classes, we're all scalar math, which is basically addition, subtraction. This one, we have to worry about directions. Now, we will do a little bit of stuff with things at weird angles to each other, but all that's required for this class is that you're taking Algebra 2 could be concurrently. In Algebra 2, I believe you start to cover some trig functions. You start doing things like sines, cosines, and tangents. Did anyone take Algebra 2 last year? Did you cover things like sines, cosines, and tangents in that class? Do you remember doing it in geometry? Yeah. I don't feel like just the geometry approach is enough to be able to be conversant in that. So I think if you're in Algebra 2 right now, you're going to learn more trigonometry. And I'm going to try to restrict ourselves to analyzing things like this that are only at right angles to each other. That means we can use Pythagorean theorem. And Pythagorean theorem is something that you cover in Algebra 1. And I'm going to try to restrict things instead of them being at weird angles. I'm just going to try to make them be right angles so that we can concentrate on the physics and not make this a math class. I do have a question for you. I'm just going to check to see if you're able to do this. If you're not, don't fret it. If I asked you to determine that angle, if I asked you to determine theta using that triangle, that Lily was saying, that's the triangle that I would draw to show 3 plus 4 is 5. Could you determine it? Yeah. Try it. If you don't know how to do it, we're going to talk about that, but just see if you can determine that angle. This is me formatively assessing where you are with your math. What's the angle of that vector? Okay, some good discussions going on again. Anyone willing to sort of take a risk here and just explain what it is that you're doing to get to that answer? Would you mind taking that risk? Thank you. I'm gonna try. Rob.
Yeah.
Rob. Go ahead, Rob. And again, we're gonna respect. If you get this thing wrong, we're not gonna make fun of you or anything like that. That's okay. What do you think?
I think it's inverse sine of 4/5.
Okay, so you could write it like this. You could say theta is equal to the inverse sine. Some of you might use an arc sine function. That's fine. You said 4/5. That'd be opposite over hypotenuse. Sine SOHCAHTOA, opposite over hypotenuse. You could do inverse sine of 4 meters over 5 meters. And when you're done, you would get an answer. Did you actually compute it?
No, I
It's okay. Anyone compute that? What did you get?
53 point, how would you point down there? So
53-ish?
53.13.
It's fine. We just call it about 53 degrees. Now, thank you. That's the inverse sine works. You could use inverse cosine. It could be inverse cosine of 3/5. You could use inverse tangent of what? Of 4/3. Because I have all three of those legs, I can find that angle in any one of those trig functions. I will probably do some right angle trigonometry like that with you here, but I don't even want to say that that's the expectation that you can do that already. I just wanted to see about where you were with that. If you are sitting there going, I'm lost, I don't quite know how to do that, we will get better with that over the course of this semester when we do more with vectors. Okay, so just relax. If you're in that position where you're like, I'm still lost in that. It's something that I intend to teach you, as opposed to intend to say that you should already know this. I won't say it's a prerequisite. If you're okay with it, you already got it, great. You'll find some other things easier than others that are learning it for the first time. So just relax if you're stuck on that. Okay? All right, so I'm going to move on from that. I want to share a couple of, well, we did this yesterday, right? We talked about motion as relatives. It's your choice. You got to be consistent throughout. I'm going to ask you to now make a distinction between two quantities called distance and displacement. They both start with D, and sometimes people might use them interchangeably. But in the real world, in physics, we have to make a distinction between them. So distance, there's a diagram out to the right there that shows that distance is along the path that you might take. And displacement is sometimes called as the crow flies. It's a straight line distance from beginning to end. Do you see that the displacement, the green arrow up there, has an arrow at the end of it? Can you see that? It's like a dashed line with an arrow. That's a clue that that is a vector quantity. It has a direction. I could measure it. I could measure the length of it, and I could measure the angle using a protractor or something along those lines. The distance has a dashed line on there, and it's got an arrow on it too. But distance is technically a scalar quantity. It doesn't have a direction. Cross-country runners. Well, let's do the car odometer first. What is your car odometer? Is the thing that's underneath like the speedometer, and it's the one that tells you like the mileage of your car. Is that mileage? Is that measuring distance or displacement? The odometer. You guys know what curious distance? If it were displacement, boy, my car would have like 10 miles on it, even though I've been driving it for 8 years, right? Because every day I start and I stop about the same spot, which means I don't travel anywhere over the given day, but it's not a displacement measurement, it's measuring distance. So my car's got to average 90,000 miles. And that's the distance. 5K cross-country races, I know we have at least 2, there might be more. You guys run the 5K. Is that a distance or a displacement? That's a distance as well. Your displacement is probably only a couple hundred meters from beginning to end when you're done. But the distance is along the path, the displacement is as the crow flies. How about the 100-meter dash? Is that a distance or a displacement? I'm talking standard 100-meter dash out on the track during like track season. 100-meter dash. Turn and tell that person that you're sitting next to.
Yeah,
Every now and then I'm going to throw some tricky questions at you. What's different about the cross-country race and the 100-meter dash? I heard something about straight line stuff. Would you guys agree that the 100-meter dash is straight line path, there's no difference between how far you travel and what your displacement is. Would you guys agree with that? The only distinction is when I have a change in the direction I'm traveling. So for some purposes, we just say they're the same thing. But other times when I have a change in direction, I have to make a distinction between those. And the reason for that is that we're not going to define something based on changes in my position. So if I started right here and I ended right there, I could talk about how fast I was traveling, which would be related to speed, or I could talk about what my velocity was, which is related to displacement. So we have to have a distinction between those. Now, I want to do that formally with you here. Average velocity, or is it speed? I'm sure you've heard of the term speed before. Raise your hand. You've heard of speed. Some of you have heard of the term velocity. Raise your hand. You've heard of the term velocity. Some of you might think that velocity is just a special name for speed. You might think it's just a fancy name for speed. It's not true. I'm going to share a story. Do you have a question? Or?
Yeah.
Okay, go ahead.
Real quick, was the 100-meter dash distance or displacement?
Both.
Okay.
Yeah, thank you. It's both because there's no change in direction, so they have the same. They have the same, let's say, magnitude.
Okay.
Okay, it's still the same. All right. So to illustrate velocity versus speed, that they are different, I'm gonna share a story with you. I'm gonna share a story. When I was a young person, 20s, for you guys that'd be old, right? When I was a young person in my 20s, I was doing some tile work, ceramic tile. Ceramic tile is a sort of, it's a good skill to have, right? To be able to build it. I was doing a shower at the time. And so it was late at night. My wife was in bed. I had 3 children at the time. They're younger, they're babies, and they're sleeping. And I'm downstairs working in the basement, cutting some tile. Raise your hand if you've ever done any tile work. Ceramic tile? Okay. There's special tools that you should use to cut ceramic tile. One of them could be a tile cutter. It looks like a table saw. I didn't have that. I was young in my age, and I didn't have any tools like that. There are other things that you can do with like a scoring and then like a little clamp that's sort of like a pair of like pliers or something like that. And you sort of break it. I didn't have that either. So here's what I did. I took the ceramic tile. It was a 6x6. I scored it along the line that I wanted to cut it on. Scored it with a screwdriver, and then I put it in a vise. And I put the score line just ahead of the vise where it's connected. And I said, okay, I'm gonna break it along that score line. And I did that by using my hand. I was not very good. So I'm like, all right, I got it scored, very good. Hit it. It didn't break. But it didn't break cleanly. And so what it did is it broke with a jagged edge right along where my hand was going through. And you can imagine what happened. And I don't want to gross shot or anything like that, but you could probably see right here, I have a big scar that goes from one side of my hand to the other side of my hand. It was a big gash. And it was bad. 10 o'clock at night, my wife's in bed, the kids are sleeping, something like that, it's bleeding. Ouch. I mean, that really bad. Raise your hand if you ever cut yourself. Ouch. So I go up and I wake up my wife, I'm like, honey, this is bad. She's waking up and she's right into the beginning of the REM sleep, right? When you're just like, you're ready to really fall asleep. She wakes up and she's using my hand, like in complete blood. And she's freaking out. I'm like, no, don't freak out. I just need to go to the doctor. So we gotta wake up 3 minutes and go to the doctor's office. The doctor looks at my hand and says, boy, Mr. Redmond, I don't know why I'm Mr. Redmond. But he's like, boy, Mr. Redmond, you got a nasty cut. You're gonna need stitches. So he goes, stitches up my hand, bring it back home. A month later, I get the bill. The bill's like $1,500. Not cheap. $1,500, my gosh, it's just a little, simple little thing. And so I'm like, I look at the bill and it says, doesn't say cut. I didn't get a cut. He told me I had a cut. He says, you had a laceration. He said, it didn't say stitches. What did it say? It's sutures. That's probably why it's $1,500 because it sounds really fancy, right? When it's laceration, sutures. It's no different than. Would you guys agree that a cut and laceration is just a fancy word for a cut? Would you guys agree with that? I wasn't sure if it was. I called my brother, who's an ER doc, and I said, "Hey, are these?" He goes, "They're basically the same thing." I said, "Are sutures anything different than stitches?" Basically the same thing. They use these fancy terms for billing purposes, all that kind of stuff. No, that is not how velocity and speed. They're not like the same thing. One's just fancier than the other. Now, I tell you that because you're going to remember that story. You remember stories. That velocity and speed are different. Speed is simply how far an object travels in a given time. That's our speed. It uses distance. Distance is along the path. Velocity is a vector quantity. Velocity includes direction. So you're going to find that you are missing the AL. You guys see that on your packet? It doesn't say AL. It just says direction. Is that true? You might add an AL there, sorry. Every year I do this. The Active Inspire software reformats things, and sometimes I miss those things that they're not there. Velocity includes directional information. We would say the average velocity is a displacement divided by time, not a distance divided by time. Now, sometimes distance and displacement are the same thing. 100-meter dash. Doesn't matter if it's 100-meter distance or 100-meter displacement, they're aligned. Other times we have turns in our path, and we have to make the distinction between those. So velocity includes a direction. I believe that we should replace these with a velocity limit. Instead of a speed limit, I believe they should be velocity limits. Who's with me?
You think drive in a loop and go as fast as you want.
Thank you. I have a story similar to this. Not driving in a loop, but let me just share. So all these things say speed limits, and I think they should be velocity limits. And I'll share the story with you is that to convince you that when I send this to the Department of Transportation to say I need some signatures, right, to say that you agree with me, it should be a velocity limit. Here's the story. I'm going down to Florida with my family. We're driving down I-75. It's the main pathway that takes us from Michigan down to Florida, right? I-75. We get off somewhere in Kentucky or Tennessee, I don't quite remember, to go get some gas and whatever else. And we get back on, and I get on the highway going the wrong way. Right? I'm supposed to be going south, but I end up getting on I-75 north. I'm going the wrong way. No, I mean, I'm going the wrong way on the highway. It says speed limit 75. And I look down, and my speed is 74. I'm fine. I'm below the speed limit. But I'm going the wrong way on the highway. 2-lane highway, you'd expect both cars going the same way, right? Well, I'm going down this way. I'm like, man, all these cars are going the wrong way. It was me that was going the wrong way. Did I break the speed limit? Was I breaking the speed limit? No. I was breaking a velocity limit because I wasn't going in the right direction. Now it's just sort of a silly. Velocity includes direction. And to be honest, when we're driving down the roadways, we want to make sure that our velocity is the right way. It has to contain a direction associated with it. So it should be a velocity limit. So I don't know if you guys are going to agree with me on that or not. I think because so few people actually study physics, they look at that and say, what the heck is this velocity stuff? So they wouldn't understand. Speed and velocity for most intents and purposes could be the same, except if we have to worry about the directional portion. Now, hopefully that story will sort of help you reinforce the concept that velocity includes a direction. I'm going to say it one more way, that speed is the something of velocity. And I want to see if you can tell me what that something is. Speed is the blank of velocity. What do you think?
Vector.
It's speed is actually a scalar. Speed is how big the velocity is. What's the way that we could say that? It's the magnitude. We would say speed is the magnitude of the velocity. You know, when I think of 55 miles per hour, that's how fast I'm going, but it's west. So we would say 55 is the magnitude of that velocity, and the direction of it is westward. So it's the magnitude, how fast you're going. Okay, now we have to, this is our beginning content, where we have a couple of equations. They're really simple, they're ratios of distance to time or displacement versus time. What I'm going to ask you to do is this. I'm going to give you, let's see, it's 111. We have till 1:30. Until 1:32, except you guys have to leave a little early. So I'm going to give you an activity to do, and that activity is to try to use these equations. And here it is. I'm going to ask you to design an experiment. I'm not going to tell you what to do. I'm going to ask you to design and run an experiment to determine if the buggy car, and I have buggy cars right behind, how many get Xavier? Right behind Xavier, there's a variety of buggy cars. Some of them have dead batteries, some of them are fine. You have to find one, so I'm going to have people do this. You don't go and get these things on your own, one at a time with it. So you're going to design and run an experiment to determine if the buggy car travels at a constant speed. So you're going to turn it on and you're going to make some measurements. I'm not going to tell you what measurements to make. Your job is to determine whether or not it travels at a constant speed. I have some things here. I have meter sticks off to the side. I have stopwatches up here. But I'm not going to tell you what to do. You need to design and run an experiment to see if it travels at a constant speed. I want a minimum of 4 data points, 4 trials. I want to see if you can create a data table and record the data that you collect through measurements. So whatever measurements you take, I'm evaluating largely to say, just what are your science practices? If I say run an experiment and I ask to create a data table and say the graph, I want to see what you're able to do. You're not assessed on this other than a formative thing. This is informative for me. I want to see where we are. Create a data table, record the data through measurement, create a graph of your data, adhere to accepted science practices regarding graphs. How I'm going to have you do that is on those whiteboards over there behind Lucas. Those whiteboards on the hoverboard are the things that I go to oftentimes when I just want to do in-class kinds of things. I'll have you write on those things with whiteboard markers, and you do the experiments on your tables. So what I'm going to ask you to do is sort of clear your tables off. So by the way, you 3 can now stay together because we have help me with your name again. Tyler? Tyler?
Well, Tyler's gonna be leaving.
Oh, you are too? Okay. How about for this? Tyler, we just jumped up with this group. I'm going to put you 2 over there so that we have enough people that we don't have to have only 2. Tyler, that way you guys have to leave early. You're not completely missing out. Okay, so clear up your tables. I'm going to have the oldest person in your mix of people, oldest person, come back and see me for the buggy car. Oldest person, come back and see me. Yeah, you? Okay, find one. Hopefully it works for you. Oldest person, come and see me. Oldest person.
Yes.
Glue? Oh, I'm sure it's glue.
Right, come and see me.
You may be doing it.
Oh. Right, come and see me. All right, who else needs to see me? Team.
Your head's so
Tyler, are you still with me? You're still with me in this class?
Yeah, no.
Okay, I got it.
Kind of remind me of like when you like
All right.
the eagle, like if you move it around like
Stopwatches right up here. Meter sticks over there. Whiteboards. Don't forget to grab a whiteboard. And then you guys are free to go. Design and run that experiment.
I'm grabbing meter stick, but I think that we should mark specific distances and then just hit the last button on the stopwatch. So don't poke me in. Yeah, you're right. I'm sorry for my action.
We can count in every second, see how far it went along the line. Either way, it's the same.
I'm gonna mark that. I'm not
So
really.
far back there, I don't even know the names yet. Okay, I'm sorry. It takes me a few minutes. Plus, Molly, you have to look over all the teams and how you know what they're doing. Does it matter when I lift it up? I would say to take the screen.
Get out! Oh, edge of class. AP brain rot. Okay, so how do you